Welcome back to talking about more factoring. So you've done a lot already, and hopefully you're getting the hang of parts of it. I know it can be really confusing because we're basically just asking you to memorize a bunch of rules. Common factoring probably made sense. The first kind of trinomials was easy, provided you could do things like write out times tables, lists of factors for numbers. And if you're able to do that fast enough, hopefully you find it not too difficult. It got a little bit more confusing with this one, and this one was a bit of an easy break. And the next one, perfect square trinomials, is something that not necessarily, you don't even have to teach it at all, because there are no questions that you could answer with all of these that you're not going to be able to answer now. But it's one of those things which is a shortcut. It's a trick. If you're paying attention, it will save you some time. Basically, it's a way to, instead of doing this one, which takes the longest, some questions will allow you to just rush through a little bit faster. So if you don't want to bother to take the time to do this, it's not absolutely necessary to learn it, but it does save some time. So remember, all factoring techniques come from doing lots of expanding and distributive property questions and noticing patterns. So this one comes from questions like this. Remember, one of the most important lessons of grade 9 was that this was not the same thing as x squared plus 5 squared, and you want to get rid of that idea as quickly as possible. You have to write it out the long way. And that gives you 4 objects when you expand. X squared plus 5x plus 5x plus 25. And what you notice if you do, two like terms in the middle, x squared plus 10x plus 25. And if you do a lot of these, you notice a pattern. I had a teacher that taught a shortcut, which sometimes it's in your agendas, this sort of thing. If you have something plus something in brackets squared, you can shortcut all of these arrows by saying it's the first thing squared, it's the last thing squared, and in the middle, you multiply them together and you multiply them by 2. So let's see if that actually works. X becomes x squared. 5 becomes 25. Multiply them together, that's 5x. 5x times 2, yes, that's 10. So that strategy works. And if you work it backwards, if you notice that this is something squared, and this is something squared, x times x, and the middle is 2 of this times this, 2 times x times 5 is 10x, then you can work all this back. So let's see what it looks like in practice. Before I go on, I should say the secret to being able to do this is you do need to know more or less off the top of your head to be able to recognize them, what all of these perfect square numbers are. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144, 13 times 13 is 169, 14 times 14 is 196, and however long you can keep that going. If you know what those numbers are and you recognize them, you will be able to use this trick. Now let's give this a shot, and again, just do some examples. So here you go, factor this, And this, by the way, is really easy to do in the section of the textbook which is called Factoring Perfect Square Trinomials. If somebody gives you a giant mishmash of factoring questions and you're not sure which rule you're supposed to use, this doesn't help quite as much, but it's a pretty good shortcut. The first one is x times x. The last one is 9, 3 times 3. So you notice that. And then you check. What is 3 times x times 2? Well, that's 6x. So because that works, I can shortcut this. This is x plus 3 squared. And that's it. Now, I could have solved this, or sorry, not solved it. I could have factored this the other way. I could have looked at the last number 9, made the list of ways of make 9 by multiplication. That is 1 times 9, 3 times 3. Notice that 3 plus 3 is equal to 6, and this could have been and that's so this method is a faster way of doing some questions, but it doesn't teach you how to answer any factoring questions you didn't already know how to answer. We'll do another one. This one is yes. 4 is 2 times 2. 9x squared, that's 3x times 3x. And you have to ask yourself, what is 2 times 3x times 2? So 3x, 2. 2 times 3 is 6. Times 2 is 12. So let's see. 12 is not the same as 24. Sorry, I shouldn't put an X there. That's a little bit confusing. So this, at least the way it's written, doesn't factor. You still have to check the other way. So I look at the first number, which is 9, the last number, which is 4, multiply them together. That is 36, and make the list for 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 times no, 6 times 6. I've already written 6, so I'm done. Can any of these make 24? 1 and 36, no. 2 and no. 3 and 12, no, no, no. So this one I get to say does not factor, and I'm done. What about this one over here? So the first one, this is 2x times 2x, good. This one is 5y times 5y. That's good. What is the middle? Well, let's see. I want 2x times 5y times 2. 2 times 2 is 4. 4 times 5 is 20. X times y is x times y. So this works. That means this is... nope, sorry. One of the 2x's here. One of the 2x's here. One of the 5y's here. One of the 5y's here. And both of them have to have the same sign. Plus, plus. That's that. And this sign is always the same as that sign. So in all of them. This one doesn't factor, but this was a plus, and that was a plus. Let's see, do we have one with a minus? Nope. So let's see this one. Let's see. This is 3x times 3x. Great. This is 2 times 2. So what is 3x times 2 times 2? 2 times 3 is 6. 6 times 2 is 12x. So that is not going to work. All right. Back to the old method. Let's see. 9 times 4 is 36. Make the list of ways to make 36 by multiplication. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5, no, 6 times 6, done. Let's see. Oh, 3 and 12. So if I do plus 3 plus 12, I do get that. So 9x squared. I will split this into 2 plus 3x plus 12x plus 4. Imagine separating the two. Look at just the first one. I can pull out a 3. I can pull out an x. No, I don't want to do that. I can pull out a 3. I can pull out an x. This leaves 3x plus 1. And on this side, both of those numbers, 12 and 4, are divisible by 4. Always remember that these are terms separated by addition. So even though I have this here, in between this bracket and this number, there always has to be either a plus or a minus. You can't have the 4 coming right up against the bracket like that. Anyway, I take 4 out, 3x plus 1. Oh, so this one does work. Okay, I pull out 3x plus 1, and I'm left with 3x plus 4. Not bad. Okay, so those are some examples. And as I say, this is not a... you could skip this entire section if you wanted. It doesn't... you will be able to answer just as many questions on a test as you could with or without it. So if I go back, so this is entirely covered by these two. If you know those two, all of these questions you can answer. And if you don't believe me, take the examples and try. But if you were observant, and in particular, if you have taken the time to commit some of these to memory, or most of them to memory, then you'll have a nice little time-saving trick, and you can use that whenever you want. If there is a topic that you would like to see a lesson about, leave a mention in the comments. We'll get to it as soon as we can. And other than that, good luck with your math homework.